I'm Tom Herbert, also known as TJ Herbert in the work environment, as there is another Tom Herbert here as well, along with about four other Toms. I began working on the floor at Bo-Mer in about 2012 during school breaks, summer breaks, college breaks, kind of learning all of our operations and really getting my hands on the products and processes. I then graduated from SUNY Oswego in 2018 and came on board full-time doing sales, engineering design, and marketing. So Bo-Mer, we actually just recently updated our name from Bo-Mer Plastics to Bo-Mer Custom Manufacturing. As our capabilities nowadays consist of more than just plastics, we really don't want to back ourselves into a corner of just plastics as our capabilities keep expanding daily, yearly, etc. We have been established in Auburn, New York since 1946. For 70 plus years, we have specialized in custom thermoforming and fabrication of plastic products. We provide solutions for various OEMs, medical, robotics, dunnage, industrial equipment, mass transit, and so on. There's really not a job out there that we will say no to right away. We'll definitely take a look into anything that comes across and see if we can help and provide a service to anybody. But as we continue to expand our capabilities, we have added a sheet metal department along with a rotational molding department as well. So rotational molding is a process Bo-Mer acquired around 2010. At the time, we were just strictly custom thermoforming, so vacuum forming, pressure forming, drape forming, and membrane press forming. We really didn't know much about rotational molding, but we took a shot in the dark. We had some luck with it, and then we've been running with it ever since. We continue to expand our knowledge and capabilities of rotational molding. One of our sub companies, Earth Planner, we produce commercial self-watering planters that has been taking off for years. Now we started in about 2010, 2011, and we continue to grow. And that is our main process in rotational molding. So you've probably used products made with a rotational molding without even realizing it. I know I have. But what exactly is rotomolding and how does it work? Rotational molding, also known as rotomolding, is a process where a hollow mold is filled with a specific amount of resin and then sent into an oven. The mold continues to rotate throughout the entire process, and as it's heated up, the material softens and evenly disperses throughout the mold and begins to stick to the walls of the mold. Then at a specific time, the mold is removed from the oven and begins its cooling phase, which allows the material to solidify. Each rotation, along with the correct speed, are critical to achieve the quality of the part. The mold does not stop rotating throughout the entire process, whether it's cooling or heating. It continues to rotate. So rotational molding is unique because it is a low pressure powder-based process that makes large, hollow, seamless parts with an expensive tooling compared to your injection molding tooling, which could be pretty costly. However, it has longer cycle times compared to your injection or blow molding, so customers have to weigh their options, figure out which one's best for their current situation. So here at Bo-Mer, we only use polyethylene for our rotational molded parts. However, the process does allow you to use polypropylene, nylon, or PVC. We just haven't gotten into those yet. Our main focus is polyethylene, as our main products are calling for polyethylene. So that makes sense for us, but you never know what the future holds. There's a wide range of colors you can use in rotational molding, since the pigments are actually pre-compounded into the powder or dry blended. There are also a lot of UV stable options available out there, which we use daily here, as our main rotational molded job produces commercial self-watering flower pots, which are constantly exposed to the sun. So that is ideal for us. The tolerances with rotational molding are less controlled compared to your injection molding due to shrinkage and cooling. Parts usually shrink about 2 to 5% as they are pulled from the mold. So you have to account for that within the design and your overall part. And it all depends, really all depends on the part geometry, the mold design, and also the cooling uniformity. So here at Bo-Mer, no matter what process it is, we are extremely hands-on. Not every product is a good fit for rotomolding. So what kind of parts and industries benefit most from this process? So rotomolding really shines in industries and products where large, hollow, seamless, and lightweight, durable parts are needed. It's really ideal for tanks, playgrounds, industrial containers, coolers, kayaks, stuff like that. Basically anywhere you need tough, hollow parts that can handle impact and the environment. Great example for this is a high-end stroller we actually produce for a customer currently. Little backstory to this, it was originally designed and manufactured for thermoforming, which we do here and we were doing here for this job, with a weatherable ABS, which worked well. However, the customer requires all of their products to have a lifetime guarantee, no questions asked. Due to the wear and tear that these strollers were getting, as you know, you're pushing a stroller, you hit a curb, it may crack or something like that. So that's what this customer was seeing. They were getting a lot of rejects from customers or returns due to roadside curbing, and the ABS was actually breaking. Therefore, we needed to come up with an alternative process, and that's where rotomolding came in. So after months of discussion, the product was redesigned for rotational molding using a weather polyolefin. In addition, by going with this process, in-mold graphics could be applied to the stroller itself. So we didn't have to post-process, apply a graphic. It was actually molded into the part during the molding process. So when should you consider rotomolding over other processes? Let's talk about the biggest advantages for OEMs and manufacturers. So the advantages of rotomolding is that the parts offer great strength and durability. They are also very lightweight, chemical resistant, and stress-free parts. With rotomolding, you can produce a variety of sizes with tools that are at a relatively low cost compared to other processes such as injection molding or blow molding. With rotomolding, you also have a great design flexibility as you can mold in inserts, threads, handles, and graphics like I just touched on with the stroller within the molding process. And then lastly, you can add foam in. So think about coolers. You can add foam in between the walls for insulation or extra stiffness. So rotational molding is especially cost effective compared to injection or blow molding, especially when you're talking about large parts. It usually comes down to the tooling costs, part size, and production volume, and really what the customer needs from their part. Whether it's, UV stable, chemical resistant, does it need great strength and durability? Does it need to be lightweight? If it's a large part and it's an injection molded part, it may be extremely heavy compared to your rotational molded part at the same size. So rotomolding gives you flexibility, but only if you design it the right way. What should engineers keep in mind before getting started? A part could be considered rotomold friendly when it is a large, hollow part that requires smooth surfaces, uniform walls, and a high durability. So when a customer comes to us with a rotational molded part in mind, we may see some flaws within their design. Some flaws may be, sharp corners, flat unsupported areas, and parts that are requiring tight tolerances. As I touched on before, that part is going to move slightly, about 2 to 5% when it is removed from the mold. So you're not going to be able to hold those tight tolerances as you would with an injection molded or blow molded part. So rotomolding has been around for decades, but the process isn't standing still and it's truly not going anywhere. So what is next for this technology? So we are always looking to expand our knowledge within rotation molding as we are with all of our processes here at Bo-Mer. One thing I would like to touch on is there is word going around that there may be actually a new material that has the possibility to cut the rotational molding process almost in half. So nowadays, the rotational molding process, it takes about 40 minutes from heating to cooling, getting that part off, no matter the size or shape. So that would be huge for the industry as a whole to be able to cut down that cycle time almost in half. So the next few years, we are going to continue to grow with rotation molding as we hope to do with all of our processes here at Bo-Mer. We recently actually just purchased a 35,000 square foot facility with 30-foot tall ceilings, which is ideal for this process as this process is basically large ovens. So the facility tends to heat up pretty well, especially on your hot summer days. It get pretty hot in there. This will allow us to have more machines and larger machines, providing more space for operators to be able to work, produce larger parts and more parts. This is also allowing us to open up part of our existing building where rotational molding currently exists to expand our footprint in our other processes such as custom thermoforming. In general, it is more cost effective as we move forward and continue to grow.